Hello there, and welcome to the MELLIOTT Minute. Today we take a look at something that we don't see very often. And if you follow me back here, we're going to be talking about these divots that you see here in this mantle. This is the result of a tramp event, we call it. A piece of tramp iron has come down here. The first ding is up here, and then progressively, this piece of drill steel, we think it's drill steel, has dinged it 1, 2, 3, 4, 5, 6 times, 7 times. And the problem with that is, as you come down here and the steel won't compress anymore, and the top has lifted as much as it possibly can, that uncrushable force has to go somewhere else. And what happens is this part gets pushed down. The top has lifted as much as it can, the steel has compressed as much as it can, and there's nothing left to give but for the force to go downward. We're going to take a bit of a closer look here. Now, what we're looking at here on the outside is the mantle. And as the mantle got dinged, most of the force appears to have been taken up by the backing behind the mantle. The backing is what sits between the mantle and the head and sides. We have examined the entire crusher, and it looks like the backing is what took up most of the force that could not be taken up by the tramp iron relief system. So when it got down to here, we're thinking that what's inside, the backing in other words, is what took up a lot of that crushing force. Now that piece we just looked at sits on top of this piece. So we looked at the head, this is the eccentric, and between the head and the eccentric is a brass bushing that fits over here. When the tramp iron relief system cannot give anymore and that crushing force from tramp iron has to push down, there's a thin film of oil that separates these pieces. This piece here spins around and the other one spins independently of that. If that thin film of oil is no longer there to protect the parts, they start to grind up against each other. They start to spall, they start to pit, and basically could crack. Is that correct, Buck?
That's correct.
Buck says that's correct. Now, that's one bushing. Here is the next brass bushing that sits on top of the shaft that's attached to the mainframe inside the crusher. Not only does the crushing force come down, it also goes sideways, so you have to think about not only does it lift things up and push things down, but it also pushes sideways. So when the force comes over here to the main shaft, it could very well bend the main shaft. And if the main shaft doesn't give, maybe the mainframe gives. So we'll take a look inside the crusher and we'll see just what we're talking about in there. Behind me here you see the cone that these parts came out of that experienced this tramp iron event. And we're going to take a look at the different pieces inside, and you'll see why a small piece of steel can become very expensive. Okay, well here we are above the crusher and we're taking a look inside. This here is the main shaft. This part that sticks up over here. And as I said, the crushing force comes not only down, but also sideways. And this part here could actually bend. I'm also going to zoom in here past the main shaft, and we're going to take a look at the counter shaft, which you see there. That would be the counter shaft. We took a look at the counter shaft inside the mainframe, which is over there, and we're going to take a look at where that counter shaft connects to the moving parts, and that would be down here at these teeth. This part here is made to rotate, driven by the counter shaft, which in turn is driven by a motor. But if you experience something like this tramp event that you see over here, then what happens is the entire machine comes to a complete standstill, and it's quite a shock load to the crusher. So if this happens to your crusher, there's a definite possibility that not only do the brass bushings get damaged, side-loaded, but you could also break off your counter shaft and the drive ring that we just took a look at over here. This one. It's very easy to knock off a couple of teeth. Okay, so to make sure that everything is okay with the machine, we dig out the specs and we start measuring pieces like this brass bushing here. And if you'll notice, we measure down to tens, hundreds, thousands of an inch. So that's one thing to keep in mind. These things crush rock, but inside the tolerances are measured in thousands of an inch. And if anything gets knocked out of spec, you're going to have a machine that will break down. Another thing that we do here at MELLIOTT Company is we make sure that everything is done to spec. Like what Buck's doing here, he's doing the torquing. And we can't just rely on snugging things down, because if you snug it down too much, you might distort something. And that's why things should only be torqued rather than snugged. We're going to take a look at the two parts that fit together. That's the main shaft.
Main shaft to your eccentric and counterweight assembly.
That's the main shaft and the eccentric that sits around it. And if you'll notice, Billy, put your finger down there where they meet, just so we can see. Just see how tight it is. Yeah, you can see how little clearance there is between those two pieces. And when a piece of tramp iron comes along, it's very likely that it'll squeeze that film of oil out from between those two pieces, and very easy for those pieces to seize together at that point, because we're talking about enormous pressures.
You should have at least 30-some thousandths interference.
Okay. Billy's saying that you should have at least 30 thousandths of clearance, and if you have any less than that, you're very likely to start seizing your pieces together and start spalling metal and doing all those things that you really don't want to. Now, just to let everybody know, it is hot today, so that's why I look a little bit damp. The next thing that we do is mount the machine on the test stand. As soon as it's assembled and ready to go and torqued down, we put it on the test stand, we run it to temperature, which is typically 2 hours. And over here, we take measurements on our computer. It's hooked up to all kinds of sensors, and we collect all the data, like RPM, temperatures, anything that could affect the machine. And when the machine conforms to all these specs, then it's ready to be delivered back to the customer. We recommend that anybody who operates a crusher installs magnets to pick up on ferrous materials, but not all metal can be picked up by magnets, so we also recommend metal detectors. We hope this has been useful to you, and we hope to see you next time.